In this video, I'm going to teach you how to do various operations, meaning adding, subtracting, multiplying, and dividing, and then how to report your answer in the correct number of significant figures based on what operation you just did. So we are going to group addition and subtraction together because the steps are basically the same. The first step is that you are going to count the number of sig figs in the decimal portion of each of your starting values. An example of this, if we have 4.056, we are going to count how many significant figures are to the left of the decimal. So we know that this 0 is significant because it is between two non-zero digits, and the 5 and the 6 are both significant because they are non-zero digits. So therefore, this number has 3 significant figures, 1, 2, 3, to the right of the decimal. For 0.1, we are going to count how many significant figures are to the right of the decimal. We know that this one is significant because it is non-zero. So we know that this has 1 sig fig to the right of the decimal. Okay, so you need to do that for every single value that you are adding or subtracting, whether it's only 2 values or 10. The second step is to add or subtract like normal. Just plug it into your calculator or do it in your head. And then the last step is where the sig figs are going to then be applied. So once you get your answer, you are going to round your answer to the same number of decimal places as the starting value with the least amount. So for instance, if we look at this first example here, if we have 4.1, which we determined up here had 1 significant figure to the right of the decimal, we're adding that to 1.315, which has 1, 2, 3 sig figs to the right of the decimal. Whatever our answer is when we actually add those, we need to round it to only have 1 significant figure to the right of the decimal, because 1 is less than 3. Okay? Likewise, over here, if we have 3.14, which has 2 significant figures to the right of the decimal, adding that to 1.1115, which has 4 significant figures to the right of the decimal, our answer, once we get it, would need to be rounded to have 2 significant figures to the right of the decimal, because 2 is less than 4. Over here, this last one, if we have 5.5555, which has 4 significant figures to the right of the decimal, and we are going to subtract 2, which doesn't have any significant figures to the right of the decimal because there isn't a decimal, our answer, no matter what it is, has to be rounded so that there are no significant figures to the right of the decimal because 0 is less than 4. Okay, so that's addition and subtraction. You are basing how you round your answer into how many digits. You're basing that on how many decimal places are in your starting values. Okay? Multiplication and division are different, but I'm coupling them on the slide because even though they're different from addition and subtraction, they are similar to each other. So we are going to start multiplication and division somewhat the same as addition and subtraction, but instead we are going to count the total number of sig figs in each of the starting values. We're not just focusing on the decimals anymore. We are going to now focus on total significant figures for multiplication and division. So once you've counted the total number of sig figs, you are going to multiply or divide like normal. And then whatever your answer is, you are going to round it to the same number of sig figs as the starting value with the lesser amount. So for instance, if we look at this first number here, this first multiplication problem, 3.14 contains 2 significant figures. We're multiplying that by 1.125, which has 4 significant figures. So therefore, whatever answer we get out, we need to round to have 2 total significant figures because 2 is less than 4. Okay? The second one here, 10.0, has 3 significant figures. We're dividing that by 2, which has 1 significant figure. So our answer, no matter what it is, has to be rounded to 1 sig fig because 1 is less than 3. This last one here, 5.555, contains 4 significant figures. If we multiply that by 8.1, which contains 2 significant figures, whatever our answer is has to be rounded so that it only contains 2 sig figs because 2 is less than 4. Now, the reason why we do this is because your answer can only be as precise as your least precise measurement or starting value. If my least precise starting value is only 1 sig fig, we cannot have an answer that has 5 sig figs because that means our answer is more precise than our starting values are. Right? If you think about like a race, I always hear people say that we can only be as fast as our slowest runner. It's kind of the same concept here. We can only be as precise as our least precise starting value for adding, subtracting, multiplying, and dividing. That's how you do operations with sig figs.